Hi everyone, the name of my graduation project is TDOA based indoor localization for wearable smart devices. First of all, I will start with RTLS systems and used areas. Then I will talk about the method with system architecture and TDOA algorithm. Finally, we will talk about experimental results, hardware development, and conclusion. Real-time localization systems are hardware and software combination solutions used to determine the real-time location of mobile transmitting devices. In this way, assets or people can be tracked and managed. In RTLS applications, operation of transmitters in broadband causes high energy consumption and low battery life. Therefore, recent work in the field of RTLS has focused on high precision localization with low power consumption. For this reason, many methods such as phase difference of arrival, two-way ranging method, the time difference of arrival have been used for localization in open or closed areas. In this study, TDOA method was chosen because it is very advantageous in terms of messaging traffic and battery life of the transmitter. Localization applications are rapidly increasing in many sectors to increase work efficiency and quality. Localization systems, which are widely used in the health sector, are also preferred by production, logistic, mining, aviation, military, and defense industry. I would like to share a few examples for better understanding of the systems. In the first example, there are 5 receivers placed on the walls. The transmitters are located on the forklift. In this way, we can manage the warehouse by tracking the location of forklifts. In the second example, employees are tracked for security purposes. In method, in localization system, the main components of the system consist of tag and anchor devices. The tag is the mobile device whose location will be calculated, and the anchor is the fixed device that calculates the location. A tag sends the signal to the anchors using ultra-wideband technology. The location data of the UVB signal detected by anchor is calculated with necessary mathematical operations in the device, and this data is sent to the server via the wireless network. In the system's measurements error made each intermediate device are added to the next device, and it prevents the calculation of the location with the desired precision. In the system, synchronization messaging is done between the reference anchor and the anchors after the tag sends a message in order to solve this problem. We can see the messages on this figure. In TDOA algorithm, in the TDOA method, after the tag sends a message to the anchors that are synchronized in terms of time, the location is calculated in the anchor with the TDOA algorithm. Equations to obtain the location are shown on the slide. If we talk about the algorithm I have developed, I will first mention some definitions. Firstly, equation 2 and 3 are calculated in a TDOA calculation function. This function takes the coordinates of the tag and anchors, and also it takes delta D values, which are the arrival time of message from the tag to the reference anchor and other anchors. In order to obtain the value of D1, the following operations are performed. First, set a variable tilde D1 with an initial value of 0 and its use as an estimate value of D1. This value is increased by small values up to the distance value between two vertex anchors called max distance in a loop. Tilde D1 value is substituted for the D1 value in equation 1, and equation 5 is calculated with the xe and ye values obtained from the equation 1. In a loop, the correct location is calculated in equation 1 by using the D1 value that is found closest to tilde D1. In experimental results, localization map. A closed area of 100 meters square was designed as the experimental setup. In the experiment, four anchors, one of which is reference anchor, were used. These anchors are placed in the corners of the room. In this setup, the location of 12 different texts were calculated. In the figure, the location where the anchors and texts are placed and 100 different locations calculated for each text. Estimated location. In the table, 12 different locations calculated with the best accuracy according to the real locations are shown. These values are the average of 100 different locations calculated for each tag. In mean error, root mean square error is used to find the margin of error by measuring the distance between the real location and the estimated location. Based on this, it was observed that the localization error varied between 0.51 and 12.71 centimeters. Circular error probability is a measure that allows to evaluate the precision of the localization system. Using this value, only the spread of the result is evaluated. In this calculation, it was observed that the circular error probability 68% values in the CDF curve varied between 24.29 and 34.49 centimeters. And hardware development. In this study, it's also planned to develop a device that will detect the weather conditions of the environment while determining the indoor localization. This device will communicate with a gateway-enabled anchor that can be connected to Ethernet. Weather monitoring results will be sent from the device to the anchor via RS-232 with NMA sentences. In this way, values of the environment, such as temperature, humidity, and pressure, can be monitored. Three main components are used for hardware. These are BME280, environmental sensor, MAX232, and STM Bluetooth. The BME280 is a combined digital humidity, pressure, and temperature sensor. This sensor is used for purposes such as indoor navigation, home automation, environmental monitor, and IoT application, etc. Some specifications and pin-out diagram of the sensor are shown in the slide. MAX232 is an integrated circuit embedded in a single chip, and it's acting as a voltage level converter. It's widely used in RS-232 communication systems. In these systems, conversion of voltage level is required to make TTL devices to be compatible with PC serial port and vice versa. The microcontroller used in this project is STM Bluetooth. The STM Bluetooth is a development board for the ARM Cortex-M3 microcontroller. The complete pinouts of the STM Bluetooth board is shown in the slide. And we can see hardware implementation states on the slides. In the results, the NMA sentences created and the values obtained are shown in the figure. In the NMA sentences, the two parts separated by commas after the $sign are specified as the name of the project. The part after P was sent as the pressure value, the part after T as temperature value, and the part after H as the humidity value. In conclusion, in this study, a TDOA-based algorithm has been developed to reduce the communication traffic for real-time and high-precision localization needs and increase localization performance. With this algorithm, it's aimed to calculate the location with a 30 centimeters precision. Measurements were made with 4 different anchors and 12 different texts in the experimental setup for localization. As a result of the measurement, it was observed that the system worked with the highest 12.71 centimeters and average 6.02 centimeters error margin. More precise results were obtained compared to the initially targeted results in the developed algorithm. Thus, high-precision localization of wearable smart devices was achieved indoors and contributed to location tracking in various areas. While calculating the location in a closed area, NMA sentences containing the temperature, humidity, and pressure information of the environment coming from the module are parsed with a gateway anchor, and gateway sends these informations to the server. Therefore, this feature will be used in some IoT applications. You can see feature works here. In the feature studies, I aim to use the algorithm in RTLS applications such as warehouse management, store management, and hospital management. This project was supported by TÜBİTAK under the 2209B program. The industry consultant of the project is Lithium Information Technologies, and I have a publication in Signal Processing and Communication Application Conference. These are my references. And thanks for your attention.